So this section is going to be talking about measures of location, which is essentially where values lie relative to the other values in the data set. So for example, like if we're doing medical stuff and looking at what high blood pressure should mean, right, it needs to be a certain amount, right, like higher than the other individuals, right? Like, are we more than, right, like, because if our blood pressure is higher than 99% of other people, we could probably feel comfortable calling that high blood pressure, right? And so that's just the general idea here, that we're going to be not just getting some measure of the overall data set, but where particular values lie relative to the other ones. And the first ones we're going to be looking at are called quartiles. So quartiles are dividing up the data into quarters. So there's going to be 3 of these quartiles. A quarter of the data is going to be less than the first. You know what? Let me just draw a picture. I think it makes a lot more sense. So if we picture just, this is all of my data put from, you know, the lowest to the highest values in my data set. And I make one cut right here, right? That splits it into 2 pieces. And then if I make 2 more cuts, now I've split it into 4 pieces. Notice I only needed to make 3 cuts. The first quartile, which you write as Q with a subscript of 1. Then Q with a subscript of 2 is the second quartile. And Q with a subscript of 3 is the third quartile. And each one of these will have 25% of the data, right, is how we split things up here. So for this first quartile, 25% of the data is less. For the second quartile, 25 plus 25 is 50% of the data is less than that. For this third, 3/4, right? It's a third quartile, so 3/4 or 75% of the data is less than that. And we should also know what's more, right? So for this first quartile, first means 1/4 of the data is less. That means 3/4 is more. Okay, so that's how we interpret these things. And these first, second, and third quartiles in math and statistics are specifically these cut points. So for this first quartile, right, suppose we were told it's like 37, right? In our data set, the first quartile is 37. What that means is about 25% of the data is less than that, and about 75% of the data is more than that. Okay, so that's how we interpret this thing. And I'm not going to have us ever calculate this thing, because as soon as we actually talk about what we want things to be in theory, it kind of falls apart once we have you know, odd number data sets or something, right? So suppose I had 5 data points, I literally can't split it into 4 even pieces. So we're not going to mess around with calculating this stuff. We'll leave that up to, you know, software or whatever in a different course. So don't worry about that. We don't need to do that. Just know these kind of basic ideas of how we actually interpret these things, right? So 1/4 of the data is going to be less than the first quartile. 1/4 is going to be between that first and second, which, by the way, the second quartile is the median, right? That's why I put that here, just to kind of clue us into that. Right, what was the definition of a median? The place where half of my data is less and half is more. Well, that is exactly what this is, right? Second quartile means 2/4 or a half would be less and a half would be more. So we normally say the first quartile, the median, and the third quartile. Second quartile is fine also, but because everyone knows what a median is, we tend to use that one. Okay, so this is all we really need to know about quartiles. Just think of it as breaking up the data into quarters, and what 3 cut points do I need in order to split it into those quarters.